to my talk. It's connecting platforms with the Kotlin DSL. I feel like a lot of people out there were told not to have speaker bio slides by Jay Gordon a long time ago, and I say, to heck with that. I get to put a picture of my cat on my speaker bio slide, so that's the most important part. My name is Patrick Cousins. I work at Etsy, and I run a meetup called Brooklyn Kotlin. We're always looking for speakers, so if you would like to come to Brooklyn and speak, just get in touch with me, either through Meetup or on Twitter. There's my Twitter. What we're going to talk about, the talk I'm going to give today is a little bit wacky. It's a little bit different from some of the others that you've heard so far. What I'm building is an intermediary between an API and a client. So, who's heard of Swagger? Oh, a lot of people. So maybe it's not going to be so wacky. So it's similar in purpose, in the same problem space, but a little different approach. So as I give my talk, I want people to keep a couple of questions in their heads, specifically 3 questions. And how would you go about solving this given your current tool set or any libraries we want to use? So how would you tell a client that a string you sent it over the wire contains HTML? How do you know if an API change will crash your app? And how do you experiment on big things like a redesign? A lot of us do iterative development in our software and our jobs as software engineers, but sometimes when you want to redesign something, a lot of things are changing at once. And so how do you make that more iterative? My tool is a DSL, and as we dig into it, I'm going to give a little bit of an overview on what DSLs are, and we're going to do a really short, really fast mini tutorial on how to create your own DSL. So who actually has created their own DSL before? All right, so you're going to get a lot out of this talk, I hope, except you. So what is a DSL? It's basically a simplified mini language. It's something that's obviously specific to your domain, but it's sort of something that solves your use case, your business logic. And it's very declarative. It can be data, functions, or configuration. There are lots of tutorials online. Kotlin was purpose-built for creating beautiful, elegant, expressive DSLs. It was one of their main design goals in the beginning when they created the language. So there's lots of things that make it really easy and make it really nice. And most importantly, it's easier to make a DSL than you think. So who here has written their own extension function? All right, that's almost everybody. Who here has written a Lambda? Okay, you all know how to write DSLs. That's all there is to it. Those are the 2 core building blocks. And we're going to look at that and see how it works. Sometimes it seems more confusing than it is, but once you get it, you'll want to write a ton of them. So we've all seen this before, extension function. It's a type, you're adding a function to it. Extension functions used in DSLs are typically extension functions with a receiver, or Lambda with receiver. You'll hear that a lot. So to show you what the receiver is, it's really just the type. It's the object that you're operating on. And so here, I'll talk about Lambda with receiver a lot. And so this is the receiver, in case you're wondering. And you've all seen Lambdas before. And then so a Lambda with a receiver is just that object that you're operating on. The this in the context of the Lambda. All right, so let's see it in practice. We're going to make a cat DSL, because we love cats. And we're just going to jump right in. This is going to be a super fast tutorial, but let's say we have a class cat, and it just has a type. So what we'll do is create sort of a factory method in which to create our cats. And if you see, we already have our Lambda in there, and that's our extension function, or Lambda with receiver. So if you look closely, that's what we're looking at. And That's the receiver, and that's the signature for the Lambda. So it's the Lambda operating upon the receiver. And so the nice thing that you can do with that is, because we're trying to create like a factory that will create cats and then apply our configuration to the cat, all you have to do is, create a new cat instance and call apply on it with the Lambda. It's super easy. And then this is your DSL. That's all you got. And we've basically created a cat factory. So to have a useful DSL, you need a bit more than this. This is sort of the core building block, but we want to be able to create a couple of these. We want multiple cats. So we're going to have to create a way to store a list of them. Let's create another class called pets, and we'll create another factory method to create multiple pets. So let's take a look at what that looks like. So just like before, we want to create our top level pets object. We apply the Lambda, and that gets us this. We're not there yet, but this is the good start. So the next thing we do is create a pets list. And this is where we're going to store all the cats that get created in our DSL. So you just need a mutable list. You make it a var. There are lots of tutorials online that speak to best practices for DSLs, but I think getting started, it makes a lot more sense to just make these things vars. Your DSLs will make a lot more sense. As you start to make them, then it makes sense to apply some of the best practices. You'll see a lot of people talk about how you should make your DSL like a builder pattern so that Java can access it. I don't think that makes any sense to worry about in the beginning. But yeah, so anyway, so we have our list now, but we have to go back to our cat function, and this is a factory, so we're still creating a cat, but we're just adding it to the list. And that's it. This is sort of the crux of our DSL. We've pretty much done all we need to do now. And we get this as a result. We can call cat multiple times within the context of pets and create multiple of them, and they are now stored in the pets list. So I feel like I have the same slide twice. No? Oh, okay. Yeah, so we just add them to the list as we call cat and create a new one and apply the Lambda. So one other thing that we can do here is we can actually use extension functions one more time so that we can create our factory method on the pets class. And so that this is really nice because it gives you context-specific understandings of the main part of the DSL. We'll come back to this and we'll see why this is important later in the talk. But this is super helpful for keeping things organized. And if you have like two pieces of your code that process your DSL differently, they can add their own private extension functions and keep this nice, beautiful DSL, but like have a different understanding of it. So it's the same DSL, just a little different color coding from IntelliJ, and that's about it. So let's talk about Sprout. So Sprout is the tool I'm building at Etsy that uses this DSL, and what this talk is really about. So it's an internal library. It's in development at Etsy. And I have a really hard time explaining to people what it is. So hopefully you all get it. But most simply, it's a code generation pipeline utilizing custom Kotlin DSL to represent the nexus between platforms. And this is sort of my fancy way of saying it's an intermediary. It defines contracts. It defines sort of the way the API and clients are talking to each other. It's the grammar that we say we're going to use when we discuss things. So at its core, it ingests machine-readable metadata and then spits out generated code. So why did I use Kotlin for this? So there's a great talk. I don't know if y'all have seen this, but I highly recommend. Laura Kelly is an engineer at Airbnb, and she gave a talk at DroidCon San Francisco in 2018. They're doing something very similar with a code generation tool, all in Kotlin, and a custom DSL. I highly recommend people check it out. But yeah. So the reason that I chose Kotlin, so the reason I chose Kotlin, I was inspired by that talk, but also because it's discoverable. Code completion and type safety help us discover like what's possible in your DSL. So when you have somebody who's working in your DSL and they hit control space or whatever, it helps them know exactly what types they're allowed to use because the DSL IntelliJ will figure out what the right types are for that context. And it's very nice for when you're trying to train other engineers. This is a common way that people explore any sort of API of like a library they're using. Is they'll just hit control space and go, let's see which one is right for this. So discoverability is huge, especially for socializing and bringing your team along, which is very important, as we saw earlier. And to me, I obviously love Kotlin. I'm known as like the Kotlin guy at work, so that's actually kind of hard to get past. But because DSLs were like a core principle and it was a core part of the language design, it's really easy to read. Like the basic syntax is no more complicated than say JSON. So these are the total characters you'll see in the DSL. And to me, that's a good thing. So it's very declarative. There's no function calls, there's no for loops, there's no while loops. It's just going to be this sort of structure of things. And then, so again, Kotlin is very helpful because it's an easy separation of logic. So as we saw earlier, you can have this private, context-specific understanding using extension functions on the DSL itself. And that can be very helpful for keeping it clean. So we saw that before with pets. We moved our cat function out of the cat class and out of the pets class to its own extension function. So back to Sprout. Let's start looking at what it looks like. I want to give people sort of an overview, a 30,000-foot overview. The next few slides may not make a lot of sense, but it's nice to sort of know what the pieces are as we sort of dig into what it does. So there are sort of 5 main parts of Sprout. The seed, the resource, the printer, the template, and the command line tool that sort of makes it all work. So let's take a look at what the seed looks like. So the seed is essentially our DSL that we've been talking about. This is the representation of the contract between the API and client. The contract is really the optionality, the nullability, and the structure of that JSON that you're getting in the response when a client calls the API. So as you can see, that's our DSL. It's very similar to what we were looking at before with the cats. There's nothing fancy going on here. It's just building up a set of objects with this metadata information in it. So let's look at a resource. If you're not familiar with resources, we're going to dig into them a little bit more, but this is a core concept of REST. Resources are, like Sprout, they are the definition of the structure, optionality, nullability of something you get from the API. So resources can have properties, and they can have other resources. So they can sort of be a tree, just like JSON. And here's our printer. Again, don't worry, this is a lot of code for a slide, but it's just good to get a sense of that 30,000-foot overview of what's going on. But essentially, this is when we want to generate Android code from our DSL, we can do that by having a private understanding of that to print Android-specific code. So we would also have like a print iOS models function as well. And then finally, the templates. If you're not familiar with templates, I don't know what to tell you, actually, but the template is just the code that we're gonna generate. And the nice thing about some of the stuff, because it's very machine readable and very machine writable, we can use Kotlin's fantastic string handling and multi-line strings without any sort of fancy templating language. So when I actually first started building that, I looked into this. I looked into handlebars and mustache, and they worked, but I realized very quickly I didn't need them at all. Kotlin could just do all this itself. So it was great. And so finally, the command line tool. This is a very important part of Sprout. This is where it all works together. And the most important thing about a command line tool is the excessive use of ASCII art and emojis. That is core. If you've built anything for any other team, make sure to put fun stuff in there. So what is all this for? I've just thrown a lot of stuff at you guys, but there is a purpose for this. And it's the nice thing about Sprout is that it can actually solve a couple of problems. So we're going to look at specifically a couple of these, and specifically API to client contracts. So this is different. I should call out, Kotlin has a concept of contracts. This is not that. Yeah, so let's go back to a resource for a second. As I mentioned earlier, it's sort of the definition of the structure, the types, the nullability, optionality of both like what you get back in response and what you're sending to an API. That's a REST API. So the guy who basically invented REST described it as the key abstraction of information in a REST resource information in REST is a resource. Any information that can be named can be a resource. A document or image, a temporal service, e.g. today's weather in Los Angeles, a collection of other resources, a non-virtual object, e.g. a person. I've known some virtual people, actually, and so on. And so that's how Roy Fielding, creator of REST, describes it. This is how I describe it. It's a unit of that API stuff that you get back. I like my definition better. Yeah, so anyways, it's request and response. It's machine readable. They have properties. And so properties are sort of your main scalar types, like string, int, long, boolean. And then you can have sub-resources, which are basically other objects. And that just starts to define the structure. One other important thing to call out is that resources can have cardinality, which is basically just the number of things you're getting back. So you can have 0 or 1 or many, only one, that kind of thing. And then, of course, it's the structure, type, nullability, and optionality. And essentially, the reason this is so important is this actually defines what your JSON is going to look like. So let's look at an actual resource. So this is actually a simplified bit of code from Etsy's codebase that describes a resource. The nice part of this is that you can pass in an object called a resource spec, and it'll fill that out with a bunch of machine-readable arrays of what this information is. So you can see we have a bunch of properties, and then we have a sub-resource here. And what that would do is it would fill it out to make it look a little like this. This is all PHP, by the way. And so Sprout has the same concept of this in our DSL. It just looks a little different. So in Kotlin, we have our spec, and we have our properties, and you can see we have user ID, nodes, comparison ID, and then we have our sub-resources. And so the thing that we do with that is that Sprout can output that same type of PHP array so that we can compare it and make sure that the API is going to be sending the same things back to us that we expect. So what Sprout will output is that PHP code, and we can then diff that and we'll be able to find if anything is missing, or the structure is different, or the type is different. And the way you do that is you step through, so these are both associative arrays or maps, however you describe it, and you step through each one and see if the other side matches. But then you have to go the other way around and step through, so you have to diff in both directions. Don't worry if you can't read this. The most important part is the title of the slide. Yeah, so why is that important? So what we can do with that is that we can run this on CI, so that before, say, a web engineer pushes a change to production, we can know, say they changed a resource and our Android and iOS apps thought that that was not null or not optional, and they removed it, they're going to crash. And they don't, web engineers don't always have that context, especially when you have big teams. And they actually really like things like this because it's basically static analysis that helps us catch things early. So the way we run that on CI, in PHP, it's very straightforward. You basically run the diff, and if anything comes back, we print out an error, and we point them to what we call a runbook that just helps them figure out what to do when they hit one of these errors. And if they match and they have no errors, we print out a little cat for them, because that's what you should do. So why is this important? Why are we, I touched on this a little bit already, but we're trying to surface breaking changes early. So as I said, API engineers actually really appreciate this because it saves them time from having to get into an emergency situation and push out a bug fix. And it also saves us money. We don't want our apps crashing in customers' hands. So, when we have things like this, like a breaking change, it's basically structural mismatch, right? And, what is structural mismatch? Say you're a JSON parser and you're running along, and something's not the structure you want, and you fall down a little bit, and it's just, yeah. We don't like structural mismatch. So that's one of the things that Sprout solves, because it gives us, just by having a DSL, we have that contract. But one of the nice things about having an intermediary is you start to actually, you've created a a pipeline for code generation. And that actually opens doors for solving other problems. So let's look at some of those other problems and the solutions to that. So one of those is we're able to, one of the key features of Sprout is that it's able to put type information into our pipeline. So why do we want this? So with the contract in place, we definitely want the API and the apps to adhere to it. But the problem is JSON is sort of a reductive, lossy format. There are no analogs when you put something in transit. So, the contract isn't, let's just look at the deck. Look at the pretty animation. So essentially, we have this type information on the API. Our API engineers took the time to say, okay, we know we're going to be sending you a string with HTML in it, so we'll call it data type HTML. And then as soon as we put that into JSON, it's just a string. We don't actually know what it is anymore. And, the way we handle that is different on iOS and Android. So how do we solve that? So what could go wrong is actually the next question. So this is one of my favorite code comments in the Etsy code base. I'm just going to read it quickly to everyone. So attention, if you are parsing strings in the base model subclass, and I bet you are, for your own safety, use this wrapper. Don't use JSON parser value as string. Assume you want all your strings stripped of HTML escaped characters when delivered by the API. If you show a string in the UI without cleaning up escaped characters, it's going to look ugly. Mother beeping ugly. That's a joke about Mother's Day in coding looking like censored swearing because it happened to me. And this was an engineer who's no longer with us, but no longer with the company, but he didn't die. But I always get a chuckle when I read this. But so we got to the point where we didn't know when we were getting HTML, so we were stripping every string of these characters in case they may have come. So how did we do that? So we actually used string utils from Apache Commons. I feel like this is a classic Android engineering question. Apache Commons, helpful or dangerous? Find out more at 11. So we use this to escape our HTML. It seemed like a good idea. We didn't want censored swearing, so it was working pretty well. But what happens when you use that too much? We're using this on every single string that comes back from our API. So I don't know if you are all familiar with the the Apache comments, what it does is it calls substring on every string, and it breaks it apart, and substring actually creates 2 new strings. So every time you do that, you're creating an object allocation. And very quickly, when you have lists and lists of strings, and nested lists and nested objects, you're creating a lot of objects, like thousands and thousands, just on page load. And so what happens when you do that? Oh, yeah, no, that's not fun. This is one of my favorite errors that we've actually gotten. They're especially helpful when you get an out-of-memory error trying to throw an out-of-memory error. And luckily, it's an unknown file, and it's an unknown method. And there's no stack trace available. So these are kind of hard to figure out. So what do we do about this? How can we solve this? So the solution that Sprout offers is what I call side channel metadata. It basically routes around JSON, and we're able to put our type information in through the code generation tool at compile time. So how do we do this? So we read that type information into the DSL itself, and then the DSL, the Sprout tool will actually recompile itself, and it will it'll learn the types as it goes along, and it starts to get a little smarter. At one point I had a Terminator slide here, but I wasn't sure if that was copyrighted. So we read these API resources for type information, and we add those new types into the DSL, and then we recompile. So this is really nice because it's developer friendly. It helps adoption. People don't have to go manually writing the HTML type. They don't. So this is basically what they look like, and nobody's out there actually writing this by hand. They don't have to. As soon as they see a new type, they have to go in Sprout and write it all out. No, they don't have to do that. It'll read it, it'll get smarter, and it'll just start adding them. Because basically on the left side here, this is that machine writable look. You can see that not much is changing between those 2 things, so it's pretty easy to generate those as well. So what does that give us? So we're able to take, if you saw in our DSL before, the types are int, string, int. And when we have these sort of more, these types with a little bit more information in them, we can then get ID, HTML, ID. And so why is that important? So, sorry, I'm jumping all over the place here a little bit, but this is the machine readable, and this is how we do that. So you can see our template, and this is the same one we looked at before, it's really just boilerplate. And your tool can basically handle all of that for you. So it reads out of the API, it regenerates itself, and then we're able to route around JSON. So what do we do when we generate that? It turns out that this is actually a fantastic use for type aliases. And type aliases are used in both iOS and Android, and they work pretty much exactly the same. So these can be generated very easily. And Moshi supports these right out of the box. It still sees that default type, not the alias. And so you can put your alias right in your little Moshi classes, and it won't change anything. It's not a breaking change. So we could have just created new objects and new types, but actually that would represent differently structured JSON. So by using type aliases, this is assignment compatible. So if we put these in, then when we're using that object in our code, say they've just read in the listing card and they want to use the currency code, they can see, they'll get the type alias, but they'll also see the actual type under the hood. And this is what Android Studio and IntelliJ will show you when you're doing code completion. So it's very helpful. It doesn't change the actual code we're writing on the client, but it gives us that little bit of information to know that maybe we didn't have to strip all the HTML characters. So they can be used on iOS and Android. It doesn't change the structure of JSON, assignment compatible, and it provides a hint to the engineer working in native code. But wait, there's more. So that was all the type generation, but there's also a bunch of information for, there's a bunch more things that Sprout can do, because when you set up this DSL and you start setting up these code generation systems, again, it's more of a code generation pipeline. So one of the things I've talked a lot about is machine readable and machine writable. I keep saying that, right? So anything that you can find that is that, like, you can then generate. You can pull it into your DSL, and you can generate it out. And it turns out one of the things that's very machine readable these days and very machine writable is styling information. So it actually makes for great metadata. It doesn't change that often, so it's not changing per user. You're not going to send a different style to, one user because their name is Patrick and they get a good style. But it does change sometimes, right? So you're going to redesign sometimes. You're going to update the look of things. So you can like change it, like generate it using this pipeline in order to update it. So how does that work? So we use this tool called Figma at Etsy. It's just how we do our designs. And we read the machine readable data from it and generate that into that. So looking at this, you should actually already sort of, in your head, something should be sticking out. This is machine readable, right? And there's some styling information here. And maybe it doesn't look like the way iOS defines styles or the way Android defines styles, right? This is totally different. But we know we have our background color here. So that's great. So we can read that in, and then we can generate it into our apps. And it turns out that it doesn't really matter whether you use Figma or Sketch or Photoshop. They all have APIs, SDKs, scripting systems, whatever. And you can really grab this metadata from any one of these systems and put it into your DSL. So the styling stuff is something we're still working on. But one of the really exciting things is that it's going to be really useful when Jetpack Compose lands. And I'm obviously very excited about Jetpack Compose. So again, I keep sort of harping on machine readable and machine writable. And the nice thing is that when Jetpack Compose lands, it's actually going to be easier to generate the code. So if we were to do this now in Android, we'd be generating a whole bunch of XML. And it's sort of not great. But when Compose lands, it's going to look a little something like this. This is actually pulled from the example Jetpack Compose Rally app. And this is how they define their styles. So this is great, and it's actually a very good example of what they call semantic UI. So semantic UI is to define things sort of by their purpose rather than, and name them by their purpose rather than what they are. So if you look at like that, the colors there, we have primary variant, secondary, background, things like that. We say background, we don't say white, right? So that's obviously white, but this is super helpful because you can have multiple versions of this, right? So you could sort of imagine we generate on one hand, in one class, like material colors 1, and then in another class, material colors 2, right? And then we could apply them pretty easily. So this is how that app applies its theme. And what we do is we'd add something like this, and now we can experiment on styling. So you could have a swanky theme or a snazzy theme. I personally think all your themes should be both swanky and snazzy. So semantic styling, generated styles, and Jetpack Compose is going to be great. I'm very excited about it. So one last thing before I wrap up is what about a UI? And I'm glad you all asked that. I'm glad I get to pretend that you all asked that. So one of the things when I was building this, it was fun to look at the command line tool, but it's sort of hard to get a sense of what's going on and what's being generated. So I wanted to see whether I could create some sort of UI, some sort of web UI for my tool. And I discovered this library called Queb, or Kwin, I don't actually know how to say that. Essentially, it's an all Kotlin library for rapid web development, and it's a really weird little beast. It basically does all the rendering on the server side, and it maintains a thin client on the client side, which keeps a socket connection open to the server. So anytime you change something on the server, the socket updates, and then the UI updates. So you actually don't do any front-end development with Quest. You just do everything in Kotlin. You do it on the server side. And this turned out to be perfect for working with my DSL. Since my DSL was all in Kotlin, like, Web could read it natively. And so it looks a little something like this. Don't worry if you can't read this. This is more, I'm showing this to give people an idea of sort of what the ergonomics look like. You can see, divs and image tags and italics tags and things like that. And this is basically how you render your UI. And it's really nice and declarative and functional and reactive. I highly recommend it for toy hobby projects. I don't recommend it for an actual website. It's a little buggy. But for a tool, for what I was doing, it was perfect. And so the end result was something really nice. So we had this little web page, and this would run the command line tool very easily. Like connecting this was a cinch. So you can see here we have our, like it reports the type aliases, it shows the DSL, and then it shows like what we're working on, some of the metadata. And you can put in new ones and add to them. So that's about it. But the reason I'm giving this talk today is that I want to sort of inspire people to realize that they can use Kotlin for things like this. You can sort of reimagine these old concepts like an intermediary. And you can put it in places where you wouldn't expect. I actually had the idea for this before they announced what Kotlin Everywhere was. But it's basically, you can put Kotlin everywhere. And this is a totally weird place to put Kotlin. But I think people can build these. They're really easy to do. And I want people to sort of know that they have these options. So in doing that, I wanted to also give people some guidelines on how, when you're building one of these things, sort of what the things are to keep in mind. And so these, for us, these were our principles and aspirations. So when we build something, we sort of, we try to think of our guiding principles when we get started so that we can, have some sort of consistency in the things that we're building. So for Sprout, our principles were that it was unopinionated. We did not want to impose complexity on existing systems. We obviously wanted it to be easy to use and easy to learn. Anybody wants their tool to be hard to use, but maybe you do. But anyways, we wanted it to be designed to grow, so it should like get smarter over time, and it should also like it should be designed so that when people hit an error, that they can figure out how to fix that, and they can figure out how to contribute to it. So, we wanted it to have runbooks everywhere. So every time you hit an error, we have this thing called Go links. I don't know who all uses Go links. Anybody? Nobody. Oh wow. You all should try Go links. They're fantastic. Talk to your corporate IT department. They're great. So you just type Go and then like some semantic string, and it will take you to a specific website. It's basically like a bookmark, but it's great for remembering things. And essentially, so if you hit an error and you put this Go link in there, we don't want people to stop dead in their tracks when they're building these. We've had a number of attempts at building tools like this in the past, and one of the things that we found that always used to happen was, somebody would build this great code generator and it would work for the developer, maybe it would work for one or two other people, and then somebody else would try it out and they'd hit a snag. And the main developer who wrote the code generator wasn't around, they were on vacation, they left the company, and nobody knows what to do. And so it became this like, oh no, we're stuck. So like building these things in from the beginning, you want to get a sense of you want to create this sense of I'm not stuck. Okay, I did hit an error. It's fine. Here I can get past it. So you go link all the things, and you go link them with runbooks. And so that's what we wanted to have a clear error message. You know, what went wrong, where it went wrong, what was expected, and what was found. And we also wanted to do one thing at a time. So we did build a code generation pipeline, but we wanted to solve one problem at a time. So you'd have like one pipe through the pipeline at a time. And the idea was that in doing things this way, that we could start adding things. We could start, you know, it's really easy to add a bunch of logos like this to a slide. Much harder to build all this, but as we thought it through, we realized that actually this could do all these things. And it's been proven in at least a number of them already. We either wrote a demo or another company is doing this. But it gave us this opportunity to sort of dream big. We could build something that would continue to grow, continue to help us. And so that's it. Thanks for all the fish.
I did have one question I wanted to ask
Sure.
about the simple errors and the clear messages, because lately I've seen a couple of situations where new code is breaking the unit tests, and there's pretty good coverage with all the unit tests, and there's like cached success where there shouldn't be, and it isn't a unit test that you touch that's failing, and it's all in the log. It's not in a report that's easy to tap through and read. How about your CI with the DSL? And when there's a break in the type, what does that look like?
Yeah, so I didn't have a slide for that, but that's exactly one of the things that we try and take care of with a runbook. So here's the error, you know, here's what went wrong, here's where it happened, here's what we expected, and here's what we got instead. And then here's a go link to some troubleshooting tips. And if you do this correctly, you know, depends on your CI, but we use Jenkins. But any CI can, you know, handle standard in and standard out. You can pipe that error through that. And so hopefully it will get those people unstuck, or at least they'll feel like, okay, there are still steps I can do, some things I can look into. That's the worst, sort of the worst thing to do to an engineer, is just to be like, oh, it broke, good luck. So one of the ways we identified where to do this is pretty much anytime you're try catching, or you're handling an error, or you write the word error in any of your code, you start to be like, okay, you know what? I need to actually output some helpful information to the engineer who's working on this, who probably hit this error. So.
Questions?
Thank you for the talk. That was really interesting. I'm wondering how many sort of other options you explored before you started down this route. Like, I saw GraphQL came up a little bit there, and there seems like there's some similarities.
Yes, so it's not something I put in the talk, but we definitely explored those things. And the ultimate conclusion was there is significant overlap in some places with GraphQL, protocol buffers, things like that. But what we realized was that having a code generation pipeline wouldn't actually hinder our adoption of things like that. It would actually complement it. And you know, if we got to the point where, say, GraphQL did handle 100% of the cases, or protocol buffers, then we could just turn this off and delete it. And we'd keep all the code that we generated from it, but we'd never have to use it again. And so that was sort of the idea. It's not, if it were to like block adoption of those things, then we would have stopped and sort of reassessed. But yeah, because they don't, protocol buffers in GraphQL don't really have a perfect migration story for when you're like updating things like the structure of something, the optionality, the nullability. They do some of it, and some of it they do automatically, which is really nice, but it's not perfect. And so we may end up using them. We may end up using them from within this. But we have, you know, a 10-year-old tech stack that's full of API REST endpoints. Our GraphQL is not ready yet. So having this kind of safety and building it in such a simple tool, this gave us something to surface those changes early for web engineers so that they don't push a change. So there was one change an engineer pushed, and this was like a comedy of errors, and they broke something, and then they were pushing the fix, and we run on GCP, and in the middle of pushing the fix, GCP went down. So, you know, these things are rough when they happen. So we want to avoid that. We want to give, you know, if I'm working on something and somebody built a tool, like we use lint, we use static analysis, they found a tool to tell me, oops, maybe you made an assumption there that's not correct, and you're going to crash something. I'm super glad to find that out early. So.
Right on. Questions?